We present a novel algorithm for efficient removal of rolling shutter distortions in uncalibrated video. Given a shaky video, here shown on top, recorded with an unknown CMOS camera, our algorithm rectifies the rolling shutter distortions and stabilizes the video. Another example, heavily corrupted by rolling shutter distortions. The novelty of our algorithm is that it does not require any knowledge of the camera or specially recorded calibration sequences. Modern cameras are based on CMOS technology, reading the image sensor one scanline at a time, known as electronic rolling shutter. Consequently, the projection matrix P for each frame varies across scanlines, depending on the speed of the readout, which previous approaches required to be known to achieve good results. In contrast, our calibration-free approach models the distortions with homography mixtures defined over blocks of scanlines. Each homography influences adjacent scanlines with respect to Gaussian weights around its midpoint. To compare our technique to other authors, we conducted a user study asking which of two unspecified methods, A and B, best reduces wobble. In these examples, our results are always on the right. Note that during the user study, the placement of our results was randomized. Another sequence comparing to Baker et al. Here we compare to Forsen and Rangaby. Our comparison to Liang et al. Here we compare to the gyro-based approach of Karpenko et al. Comparison to Grundmann et al. Lastly, we compare to the approach of Liu et al. We achieve robust estimation of homography mixtures using iterative reweighted least squares to weigh feature tracks with respect to their registration error. Note how foreground motions are discounted. Here we compare our adaptive feature extraction with conventional uniform extraction. Notice how the density in low textured regions is substantially improved. To test robustness, scalability and repeatability of our approach, we recorded 4 challenging scenarios with 4 different cameras. Here, Nexus 1 on the left, Nexus S on the right. Our undistorted and stabilized result at the top, original with crop window overlaid at the bottom. iPhone 4S with integrated gyro-based stabilization on the left, iPod Touch without on the right. Our algorithm further removes residual wobble that the in-camera stabilization cannot remove. Our second scenario, panning. Nexus 1 on the left and Nexus S on the right. Our undistorted result at the top and the original with crop window overlaid at the bottom. The same sequence for iPhone 4S and iPod Touch. Our undistorted and stabilized result at the top, the original with crop window overlaid at the bottom. The third scenario, walking sideways. The original shown for Nexus 1 and Nexus S. Undistorted result on top and original with crop window overlaid at the bottom. The same sequence for iPhone 4S and iPod Touch. Our last scenario is seen with large depth variation. Undistorted results for Nexus 1 and Nexus S. The same sequence captured on an iPhone 4S and iPod Touch. And the undistorted result. We conclude by showcasing a live implementation of our algorithm on YouTube. Here the original previewed in the YouTube editor and the undistorted result after real-time stabilization. A final example. Here the distorted original and our result after performing real-time calibration-free rolling shutter removal and video stabilization.